Okay, I believe it's being recorded now. So we talked about this is odd. I'm going to show you something funny with NPM. So NPM is odd. So we learned how to check the source code on GitHub. So if we go to the author, we'll find that he has two libraries, is odd and is even. And this is odd library has been downloaded like millions of times. He has 500,000 downloads a week. So it's pretty crazy. And you're basically just replacing one line of code, right? I mean, like this line. So you're actually adding a dependency, adding potential security risk just for one line of code. Now, even though internally it has extra checks, but you probably don't need these checks anyway. So this is the is odd source code. And if we go to index, this is the source code. This is what it does. It checks if it's an integer, it checks if it's a safe integer, and then it returns the one line that you replaced. And funnily enough, if we go to is even, we find that there's several commits, 12 commits. And at one point, someone figured even is basically not is odd. And so the code for this library is simply including the other library, which is odd, and making a not is odd. So you see, by using this library, for example, you're adding a second library, which also adds more risk. And you're really like, you're just replacing the not sign here, the exclamation mark. So usually what I tell you is make sure you really need the library before including it. And you can see that this library was developed in 2014, and he was just learning how to program when he created it. So it's really funny how a lot of developers will just include dependencies. Okay, so we talked about promises, async, and callback hell. I'm not going to go through them again. I just want you to remember that we can add async to any function in Node.js. And when we need to await an asynchronous call, we just add the await keyword before calling it. So we have an asynchronous function, and then we await an asynchronous call. So this will run synchronously. And then we await another call. So this will run synchronously as well after the first one is already done. And then we're returning some result, and that's it. And when we call this function, we can either call it with await before it, which will make it run synchronously, like wait for the result before continuing, or we can just call it directly without the await. So it will run asynchronously and go into the second line directly. We compared Node.js with other programming languages, which I'm not going to go over. Now, this is new. This is for our talk. This is where our talk, the sequel, continues. So to start, what's a RESTful API? So we all know that an API is what exposes our functionality as a library or as a layer of connectivity to different third-party services or to the front end. Why do we use APIs? When PHP first started, there was a huge fuss about it because you could render the front end right on the server. However, that turned out to be very limited when mobile apps started getting traction. So when you have a mobile app, you do not want to give, for example, the admin user of the database inside the app. And that's where APIs, like RESTful APIs, started to get more and more popular. And RESTful API is basically a PhD thesis. And it was first published in 2000. And since then, it's been improving and a lot of things have changed. The first thing that we care about when we talk about RESTful APIs is uniform interface. So maybe you have many different APIs, but they all should look the same to the one calling your API. So let's say you have a microservice which cares about video playback. So just plays and pauses, and another one which adds a video to the queue. So these are two different APIs, let's say. To the end user who's actually using your API, they should be uniform. So it should be very difficult to tell that, hey, internally, this is a completely different service. The second thing is the layered system. And this, of course, helps with scalability. So this is an example of an orchestration layer, and the orchestration layer talks to the models, and the models talk to the helpers, and the helpers talk to a polyglot system. So it's using multiple different databases at the same time. The thing here is to make sure that one layer has access to only one layer at a time. Of course, there are exceptions sometimes, but the general rule of thumb is split into layers so that you can scale whatever needs to be scaled. Like in the old monolith architecture, you would scale the whole server, which contained everything, the database, the models, the backend, the front end, everything was on the same server, and you needed to scale the whole server. But nowadays with layers, you can have the database on a server on its own, and you remotely connect to it from the backend, and the front end is on a completely different server on its own as well, which helps with scaling. So if you need to scale the front end on its own, you can do that. If you need to scale the database on its own, you can do that, and so on. And the third thing is that it should be stateless. So for PHP developers, again, the feature which was a huge deal back, I think, in the early 2000s is the session. We had a session and it was amazing. You could store whatever user information you need. Like if you had a cart, for example, you just add what items this user has in his or her cart, and it would be in a state which is validated with every request. So whenever I make a request, I know that, hey, this request came from this user, and this is what he has in his session. This introduced a lot of problems later on. Every request is independent of the other. The backend should not remember what happened in the previous request. So even if a request is lost, or if we have a completely new request, whether it's from the same user or not, it should not depend on previous requests directly. So the state should be separated. And we usually do this through the authentication token. We get the token, we know which user is talking to us, and we get the state from the database, not from the front end. More about this can be found here and here. Yeah, go ahead.
Excuse me. Could you make it clear, are these 3 different types of APIs, or are these all qualities of a RESTful API?
So these are all qualities of the same RESTful methodology, which defines the REST API. So this is the link which I'm referring to. So we have 6 things. The other 3 are on the next slide. And what I'm talking about is stateless. So all client-server interactions are stateless. The server will not store anything about the latest HTTP request the client made. So it doesn't matter what the latest request had. I don't need to check it. I don't need to have them in sequential order, and so on. There's no session, no history. Of course, there is something very similar to session, because at the end of the day, you need to know what's in the cart, right? But this is stored in the database and is retrieved with every new request. Okay. So then we have, it needs to be cacheable. Now with RESTful APIs, it's like way simpler than it used to be before RESTful APIs to cache data. And that's because with RESTful APIs, we use verbs. I'm going to go into the details, but if you remember from last talk, we talked about the main verbs we use, which are get, patch, post, put, and delete. Usually what happens is, in the beginning, you simply cache all the get requests. The other verbs are not cached. This is just the general way in the early stages. So you never cache a put request or a post request or a delete request, because you're actually manipulating data in the database. So you're caching the things that are retrieved from the database. So as you can see here, you have the caching layer and then the actual service. So when you're manipulating something in the database, you actually need to get into the service. You do not want a cached response. But when you're getting information, if there's no database change, then usually, in most cases, it's safe to just cache that information. Now, client server, this is just a meme. This is not always the case. It shows you how the front end is always nice. The backend is usually not as nice. And the thing with RESTful APIs is that the front end can be completely separate from the backend. So this is opposed to what the early stages of PHP was, where we would just use a template and generate the HTML right on the server. Nowadays, what we see is a completely separate front end, which uses AJAX or some communication protocols like MQTT, for example, in order to get updates. And then once it gets the new information, it actually updates the front-end elements. So this is the separation between front-end and back-end. This is another property of RESTful APIs. And there's the code on demand property, which is totally optional. However, I don't think this applies anymore anyway. This was back in the early 2000s. And back then we had Web 1.0, where we did not have any variable web pages. Like everything was just static, right? And so they introduced the possibility of the dynamic content. However, nowadays, everything is dynamic anyway. So in my personal opinion, this doesn't really apply anymore. And it's optional anyway. Okay, there is a link here for best practices in REST API design. You can definitely check that. So now let's dive into our solution, which is a full database API. So this is the project. If you remember from last time, to start a new project, we install Node.js in the beginning. So Node.js will automatically install NPM as well. NPM is the package manager which deals with all the packages of Node.js. All we need to do to start a new Node project is to have the dependencies in the first place, which are NPM and Node.js. And then we go into shell or command prompt if you're like me on Windows for now. Oh, I don't even have. Yeah, no, let's just sit. And I'm going to cd here. Okay, so to start a new project, you'd say npm init and follow with the prompts, which will create a new package.json file for you. Right now, we're not going to start it from scratch. This is what we already have. When you create a new project, you will not have the dependency part. So this is what you'll get with a new project. Once you add the first dependency, then you have this part. Not all of these packages, but you'll have the dependencies part with the dependency you just added. To add a dependency, what you do is npm space I, which stands for install, and then you name the package you need. In our case, we need all of these packages, and we'll see why in a second. So we need the body parser, .env, express validator, low-pick. And so I've done each of these separately, and then I added at the end. So let's say I wanted body parser. I'd say body-parser --save. So --save actually goes into my package.json and adds the dependency. If I do not save it, then the package.json will not add it as a dependency. Another thing is that sometimes you may want to install things globally. So you would do -g, which means install globally. This is outside the scope of the current talk. I'm just so that you know anyway. By installing globally, it means you can access it in your command prompt or shell without, like from any project, not necessarily from this project specifically. Okay, let's go into the index file and start from there. So I'm going to share this code, by the way, with you. I'm going to share with you this folder. So you'll get the hello world application, which is a one-liner. You'll get the server we created last time, and you'll get what we're creating now. And you'll get both PowerPoint presentations as well. So to start with, I added .env. This is totally optional. I added it because it's a hugely recommended best practice. What it does is it lets us define variables on the environment level. So let's say I'm going to open the template file. So what I have here for dev.env, it means that I can have separate environments. So one for development, for example, one for staging, and one for production. So I'll show you the template. I'm going to copy the template and rename it to prod.env, and then I'm going to access it. So these are things I preset. I have a listener port, I have the MongoDB user and password and URL because I'm accessing it remotely. So I can have the different configurations for different environments, and they would be automatically loaded by my manager. In our case, we only need one environment, which is dev, and it has the actual password. So, but you can see the general idea from the template, which are these. I just changed these to the actual values on my PC. Okay. So starting with the index file, that's what .env is for. It loads the environment. And config is the same thing. It's just the configuration for .env. You can actually access these files if you want. Otherwise, you can just use them as is. You just copy the files and they work automatically for you. Then we're going to need Express. Express is what allows us to define the different request types. So as you can see, app.post. We have the app, which is also by Express. So you can see app equals Express with the function being called. Again, you don't really need to understand what's going on behind the scenes, even though if you do, that's amazing. You can just copy the code and it will be working anyway for all the projects you have. The body parser is what allows us to parse the body of the request. So the body could be JSON or could be URL encoded, which is this type of encoding. There are many other encodings, but these are the most popular. We need Monk, which is going to use MongoDB. Our next talk will be about the different database systems, mainly focusing on collection databases, which MongoDB is a collection database, and graph databases. Next, we're going to use the Monk to access the actual database. As you can see, I've used process.env.mongodb user. If you remember, this is from our environment, this one. So this is how we access the environment variables. And this will change automatically based on which environment we have selected. Now, we'll not learn in this talk how to change environments. However, the default environment will always be dev. So it's going to load my configuration from this file here. And then it's getting the password and then the MongoDB URL, and then it's going to access this database, which you can see on my local machine. Well, actually, it's not my local machine. This is hosted in Azure. Okay, so we have a DAL demo database here. I've already included one document, which is expenses. We're going to delete it and create a new one, but I need you to see how the get works first. Okay, so what we have here is we're including the Express validator. We can go to the Express validator documentation if we wanted to learn all the details about it. For now, all we need is query is the function which checks whether the URL query, mainly in GET requests, has specific validation rules. We're going to go over this in details. And same for body. The main difference is that this checks in the URL, this checks in the body of the request. And then the validation result is the actual validation result, as the name suggests. And we'll see how we will accept or reject a request based on validation. And we have a controller. So just because of best practices, I'm trying to enforce a lot of best practices here. I've split the code into controllers, models, and an index file. What we're seeing here is the index file. In order not to have all my code in one file, I split the code into separate files. And there are multiple methods of doing this. Among the most popular is MVC, Model View Controller. We're not religiously following it here. However, it gives you the basic idea. So we need that controller, and we'll see how we're going to use it. Then we connect to the database. So db.then connected to the database. So this is what we're going to get in the console once we run the application and it's successfully connected to the database. And then we're going to say support parsing application JSON types, which is the JSON body of a request. So app.use is using the Express library. And then body parser is the body parser library. And we're specifying that we want to allow JSON. And the same thing goes for URL encoded. We can check the documentation to see what extended means. It's just one of the options of URL encoding. And then...
excuse me if I may. Is this on the server side or on the front end side?
All of this is just the server side. We're not going to talk about anything in the front end side except making the actual request where we're going to use Postman.
So all this is setting up how you're expecting to receive requests and like where you're going to process it through with the database and everything, right?
That's true.
Sorry.
Yeah, this part is the API part. Okay, looks good. We'll get into Postman in a few minutes. Now, this is what we call a middleware. A middleware is something that runs between when you first receive the request and when your actual request function works. So what happens here is we have a wildcard. So what
Can you say that word again? What is it called?
It's a wildcard. Yeah, it's a middleware.
A middleware? Okay.
Yes. So what this does is whenever I get a GET request, no matter what the path is, I'm going to do this. And this is called a middleware because this runs before this. So I know that when I have a GET on my domain name /expense, I'm going to do this functionality. However, I have a middleware here which is also for GET requests, which is going to run before that one. And what we're doing here is that we're merging whatever we have in the URL query into the request body. And this is, I wouldn't say that this is a best practice. It just makes things easier in the way I have made this template. You can choose not to merge them. That's totally up to you. It just makes this talk easier. And so, and just so that you know, for those who have not worked with APIs before, what I'm talking about here is when we have a GET request, we include the parameters in the URL. So a question mark, the ID, for example, is this. However, when we're making a POST request, for example, the parameters are not sent through the URL. So this is what we're talking about. The query, which is usually utilized in GET requests and which makes parameters get passed in the URL versus what we get in the body of the request. So what this does is it gets whatever we have in the query and it adds it to the body. And if it already exists in the body, it overwrites it. And this makes it easier for us in this talk and in this project to just care about the body. So we don't really have to care about the query, because whatever there is in the query is going to be added to the body anyway. Now, this is another middleware, as you can see. And this applies to all requests. So this only applies to GET requests, while this applies to all, whether they're post, patch, options, whatever that is. So in this case, we're logging the request method, which is the verb of the request, like post, patch, and so on. That's a very good question. Please don't utilize chat. I'll not always keep an eye on it. Next means go to the next thing, because this is a middleware, right? So it needs to know when you're done, and it can actually continue to the next thing. So the next thing to this, in this example, for instance, is to go here. So without this next, it's never going to reach this, because it never knows when you're done. Why it's built this way? It's because Node.js is built with asynchronicity in mind. You could actually go next without waiting for an asynchronous call. And this is, I think, yeah, no, we're not utilizing it right here. However, if we had some async function call like this, what this would do is it would run the function, and then it would go to the next middleware or the end result, which is here, directly, without waiting for our async function call. Otherwise, I can add an await, and now it will never go to the next one until this is done. So this gives us a lot of flexibility, lots of options. And then we've defined a function which is not valid, and we have a constant, which is validation, which is using validation result. If you remember, this is from Express Validator. So it runs the validation on the request. And we check if the validation error's length is valid, which means it's not undefined and it's not 0, then we log that, hey, there was an error, and we return the errors. Otherwise, we just return false, which is basically, we should be returning undefined. But, oh, OK, just for the naming convention, because I named it is not valid. So no, it's not valid. OK, so the next thing we're going to look at is the actual. So for now, we can ignore these. These are the different types of our API. So what our API is going to do is manage expenses. We can post an expense. So we can create a new expense. This is the endpoint which does that. We can patch an expense, which means we update it. And we can get an already existing expense, and we can delete an expense. For now, we do not need to focus on these. We will get back to them a bit later, just once we're done with this, because this is the easiest. And finally, so we're going to talk about this next. Right now, I want to show you the console.log. Magic happens on this port, which is being loaded from the environment, and the app is listening on the same port. So when I run this app, the first thing that's going to happen is it's going to require all of these and define all of these constants. Well, constants in JavaScript are very interesting. You cannot reassign a constant. However, if the constant is an object, you can modify the object. And this goes into the semantics of how JavaScript works. I'm not going to go into the details. However, I want you to know that if, for example, I say const obj equals new object, I can later say obj dot some parameter equals true. This is valid. And the some parameter in the object will become like this. So it will become like this. Some param is true. And this is very valid because the constant itself is the pointer to the object. So the pointer did not change. So this is just a side note for you. That's why we used constant, even though sometimes we may have some things change. So it's going to do all of this. It's going to try to connect to the database. However, this is not awaited, and this is an asynchronous call. So we may get this before it logs connected to database, because this is going to take some time. So we may get magic happens on that port, and then we'll get console.log, because this is asynchronous and we're not awaiting. And just a side note, for this version of Node.js, which I'm using, I think it's up until 10, you cannot await on the top level. So I cannot do this. This is going to change in a future version, which is currently in beta. However, for now, you can only await inside an async function, not at the top level. In a future version, this is going to be possible. Let's do this. So I'll go to the I still have this. I'm going to say node index. I don't know why it takes more time when I'm sharing my screen. This usually happens. So it's saying magic happens on port 3000 and then connected to database, which is exactly what we expected, because connecting to the database requires an AJAX call to the remote database. And it's telling me there's something deprecated. Okay, so listening to events on the database class has been deprecated, which means I need to check what exactly in either in Monk has changed. So something in the library Monk, which is managing our database connection, has changed, and I need to check the documentation in order to find out how to follow the new best practice. Okay, another thing is that this is not using best practices either. What I'm doing is I'm including the database connector into the body of the request. And this, we'll find out in a few minutes why I'm doing this. This is not a best practice. I'm just doing it to make things easier for this talk. So let's look at get. So what get does is if I receive a get request at this location, so which is my URL, in my case, it's localhost colon 3000 because I'm using the port 3000, not 80. If I was using 80, then that's the default in your browser. No need to include the port. However, I'm using port 3000, so I need to say localhost. If I was using port 80, I wouldn't need this part. It would be just localhost slash. Okay. So I'm gonna make a get request, and I'm not going to include this parameter. So expense, and that's it. So you see what I did? It's supposed to check. This is in the documentation of Express. You include first the path, and then you include the validation parameters, and then you include the actual function which needs to be run. So if we receive a get request, which is defined here, to this path, which we just did in our browser, we need to make sure that _ID parameter exists. And then we run this function. Now, this is the condition. If this condition is false, it does not do anything. It will still go into our function. And this is something that has been changed in the recent couple of years, I think. Before that, it was a completely different thing. Now it continues anyway, and it requires you to make the validation inside the function itself, which gives us more flexibility again. So what we do is we first check if it's valid or not, which is the function we went over before. If it failed, which means it's not valid, we return a status 400 with the following JSON. Now, this is another property of RESTful APIs. You need to utilize the error codes. So in this case, 400 means bad request. The request was missing something. It failed validation. So we're returning 400. In some cases, we might have a database error, which means internal server error, which translates to an error in the 500 range, which means internal server error. Anyway, so when validation fails, we're returning 400, and we're returning a status code message. You don't really need to return an HTTP code. I'm just doing it for the sake of the talk, and the meta, which includes what happened. And this is exactly what we get. We get a status, code 11, the message, the HTTP code, and in the meta, we get invalid value for the parameter _ID, and the location is the query. So this query here is missing an _ID. Let's say I say ID equals 1. I'm not sure if I added, I think I did not add a handling to that error. So the error I got is argument passed in must be a single string of 12 bytes or a string of 24 hex characters. Honestly, I'm not sure what happened. One should be valid. Okay, we'll debug it together. Even this was working before. I'm just not sure what happened. Okay, so what get expense does is if it did not fail, we are going to go to the controller. Remember when I told you I split the code? So it's going to the controller's expenses, which is this file here. And then it's going to get expense, and it's going to send the request body. So get expense, which is this one here, and it's going to post the request body into parameters. And the callback is result2. Now, this is another property of JavaScript. You can actually pass functions. So here I'm passing a function. This is exactly the same as saying function, temp function, or anonymous. We call them anonymous functions. Anon function and a parameter of the anonymous function is going to be returned. So when I call this function, I'm going to pass a parameter. And once this function is called, it's going to run what's inside, right? So it's going to return the result2, which is the parameter.status.http code. So this is exactly the same as this. So it's going to return the status, the HTTP code in the parameter. And it's going to return the JSON in the JSON format, the whole parameter.
Sorry, in my notes, can I call this endware?
Well, that's not the real name, but if it makes you understand things better, then sure, why not?
Okay, sure. But this app patch and app get, that's not the same as the middleware, right?
We call these endpoints. These are the API endpoints.
Endpoints, okay.
We actually call this, so these are usually split into a router file. Usually we do not include these inside the index. I'm just doing it for the sake of the talk because this is just a quick introduction. Usually we have these inside the router on their own, and each of these are called endpoints. And with big projects, we even split the router into multiple files. Okay, so I'm going to call this function, which is getExpense, which is this. I'm going to fill in the parameters, which are request.body. And I am going to send a callback, a function. So once I'm done here, I'm going to call the callback. So as you can see, return, call the callback, and insert this as a parameter. So this will fill the result2. Now, as I told you before, callbacks, we used to have something called callback hell, and that was bad. And now we have the async await. However, this is a different case. We are not going to get a callback hell from this. Callbacks are not evil on their own. They are evil when you make a hell out of them. So this is not a bad practice, even though it's using a callback. And what this does is basically just run this. Once you're done, let me know. How do we let you know? We use the callback. So what this does is await get_expenses.find_one. This is self-explanatory. It's using Monk. And this is, remember when I told you this middleware is injecting the database into the body? So the body.db now has the actual Monk connection. This is how we're using it. Params. So these are the params which we passed as request.body. And in the middleware, we filled the request body.db with the database connection. And now we're using this database connection over here. And what you see here is you can find in Monk documentation. So what we're doing is go to MongoDB, get from this collection. So this is the database. This is the database we're using, dal_demo. We have many collections. We're using the expenses collection, which you can see here. Find one. So we need only one result, which is _ID. This is the query. This is how we query MongoDB. So the query is _ID is params.id. Now, I think that there is an issue with params.id. I think it's getting it as empty. I'm going to do a console.log params._id to see what's happening. So now I'm debugging this with you. There is a better way to debug Node.js. You do not need to console.log everything. However, it's out of the scope of this talk. So I'm just going to do it the bunga way. What do they call him? Okay. Oops, sorry, I posted. I meant to get. Let's check the get first. Yeah, getting from here is working while getting from the browser is not for some reason. Let's see what's happening.
You are using UUID and the length is small.
Okay, let's try. So let's use an actual length since you may be right. I'll just change 3 into, actually, let's keep it at 3. Okay, you're totally right. I must have added an index and forgot. Oh, yes, you're totally right. I'm so sorry. So what happened here is I'm using the default MongoDB ID. I did not define my own. I'm so sorry. I created this project last time for the last talk, and I just forgot what I've done. Thank you so much. So what happens here is I'm using the internal ID of MongoDB. And as our friend noted, it has to be of UUID type. You can look more into UUID if you'd like to check out more. So it has a specific type which we need to adhere to. And now that we've included a correct ID, it has gotten it for us. Now, this is what we see when we call a RESTful API if it's in JSON format. A RESTful API does not necessarily need to be in JSON format. It could be in XML. It could be in YAML. It could actually support multiple different encodings at the same time, depending on what you want. However, it's the most common. The most common is using JSON, and that's what we're using here. So if I wanted to see this in a proper way, I'm not sure if I have it bookmarked. I don't think so. So let's see JSON viewer. So this is what it is. It returned the status, and you can see in the meta the actual object. So this is our expense. The internal ID is this. The name is test. The date, well, I didn't fill in a proper date. This is the date added, and this is the amount of the expense. Of course, this is, I entered this earlier. So now we have two of them because I also entered one while debugging by mistake. Okay, so let's delete them. So I deleted them from the database directly without using the API. Now back to the API, we've seen how it fetched them from the database. And if they are not found, we would have gotten a status saying API not found with a null meta. Now that they're deleted, we can run the same request again and it will not be found. And you can see that we received a code 3, HTTP code 404. Now I'm returning the HTTP code in the body. This is not how we see the HTTP code. I'll show it to you in Postman anyway, and meta is null. So I'm just trying to say that you do not have to include the HTTP code in the body because you can see it in the front end or in third-party callers anyway. Okay, so if we didn't find it, we'll return not found. If we found it, we'll return success with the result. Now, what's API status? API status is a model that I'm requiring here. So I'm requiring two things, pick and API status. We'll see what pick does in a minute. And for now, we're using the API status, which is models API status, which is this. So this is a model I created. It's simply an object. And success, for example, is an object which has code 1, message success, HTTP code 200. And so on for other common stats codes. And that's it. And this is how you extend your index file. So you define a module.export equals object, and the object, you just define whatever the object does. So see how this is defined and how I'm using it here. I just required it, and then I can directly access the object. So not found, for example, would be this one, directly accessing the object itself. And the same thing goes with defining the controller. So this is a controller. We said module.export, anonymous object, and the object has parameters. And the parameter itself is a function. So getExpense, for example, is an asynchronous function which takes parameters and has a callback. And then in order to call it, I simply require this whole file in here. See this line? I'm requiring the whole file, and then I can access directly the object. So expense controller dot get expense, which is a function, and I call the function directly with whatever I need to pass as parameters. Okay, any questions?
Well, yeah, what would you call that expenses.js file? Like what type of file is that?
So all these files are JS files. They are JavaScript files. However,
yeah, but in terms of like where they fit in like the structure, you know.
So this is so as you can see, the structure we're using, and this is not the only standard. There are several standards you can look up: MVVM, MVC, MV. There are a lot of them actually, and they are not really concrete. Like you may find someone in MVC swapping the models and the controllers. It happens. So the most important thing is to understand the idea, like why to split the files in the first place? Why to split the model from the controller? Why not just have them in the same file? Because let me tell you, it's easier to develop in one file. Maybe not in one file as in everything is in the index, but maybe merge the controller with the model. However, there's a lot of advantages of splitting them. And this is what you can look up and find out. Okay. So we're almost done. The rest is the same. If we just understand any of these, the rest are exactly the same. So I'm just going to go over one of them. So let's say new expense. New expense is exactly the same except for two things. Where's the new? This is the new. It's a post request. So we post to expense. So as you can see, it's the same URL. All of them are expense. However, what's different is the verb of the request. So if we post an expense, we need a name, a date, and an amount, and we do not need an ID. And these need to be in the body, not in the query, as in here. And okay, and then we have our callback, which is asynchronous. Why is the callback asynchronous? Oh, okay, yeah, because we need to await for something to happen. Okay, so see this, async. This is in order to be able to await. In this particular case, we really don't need to await because this is the end of it anyway. Oh, well, actually we do because we have a catch block. Catching, if we did not await this, and we had an error in it, the catch would not work properly. You would get a completely different error. I think it's deprecated, but it will still, I'm not sure. This is a version thing, but from a certain version onwards, you should not get an error from an unawaited asynchronous call unless the try catch is inside it. So for example, this try catch here, if this is not awaited and an error happens inside this function, this is a big problem and it will not be caught properly. So because we need to try and catch properly, we need to await it. Now again, last time we talked about awaiting multiple requests. However, these requests running asynchronously. So for example, if we go back to the PowerPoint, this is a really quick note. What if these two were not dependent? So in this case, we await this to finish and then fire the new function. What if we wanted both to finish, however, they are not interdependent? So this could finish on its own and this could finish on its own and they do not. So fireworks is not needed here. Then we can use an async library, and we mentioned it last time, such as this. We would use async.parallel, and we would include the two functions, and then we'd include a callback. Once both are done, we're going to do something. However, each of them will run asynchronously. So we do not have to wait for one to finish until we start the other. And this applies here as well. So if we had several things that are not dependent on each other, we can just use async.parallel and then await the final result. OK, so we need to make sure that all of these exist. And this is new expense. So the thing I'm going to tell you about is very dependent on document databases. Because in a document database, it's not strictly typed. So you do not need to specify a type of the parameter in the document. And you do not need to specify the parameter in the first place. So you do not really need to say, as in, let's say, C# or C++, my object is of this type, which each parameter has a specific type, and you cannot just add things dynamically. So for example, let's try this. Let's say I wanted to add a new feature. Expense also has, let's say, pay2. It's as simple as this. Now my database can accept pay2. That's it. I did not need to go to the database. I did not need to go to some place and change the class. It's not strictly typed. I can just add whatever I want, no matter the type or anything. So what we're doing here is I'm picking from the parameters the things that I want to go to the database. Why? Because if I did not do this and the user added more stuff, like for example, pay2, and I'm simply adding to the database the parameters as is without this line, then the user can fill my database with whatever they want. They can add new fields if they wanted to. And this is why I'm selecting from what the user is sending me, I'm selecting name, date, and amount only. So now if the user sends pay2, for example, it will just be discarded and it will not go into the database. So this collection of the things I want are added to CRUD params, and CRUD params.date added, I'm adding the date added in the backend so that the user cannot change it. And then I try, because this is a database thing, I try to insert the selected parameters into the collection called expense. And this is awaited because I need to know whether it actually worked or not, as we said. And if not, I need to catch it gracefully. And then I return the callback, which says it succeeded, and here's the result. Otherwise, I would have an issue here, and it would catch. It would console.log, and then it will return a callback saying, database error, and here's the error. Now, again, best practices tell you that you should not pass the error as is. This could reveal information about your database. However, this is outside the scope of this talk. We're not talking about security. We're not enforcing all best practices. This is not production ready, even though it works. OK, so this is it. Any questions? Of course, we're going to test it, and we're going to test update and delete as well. But any questions until here? Yeah, go ahead.
I don't know if it's only me or it's due to Zoom or something. Why am I seeing hyphen instead of equal to everywhere?
Hyphen instead of equal to.
Like say, for example, the line UR, constant CRUD parameters, params, line 7.
Yeah, so, line 7.
Sorry,
word?
6.
6.
So before pick, it's equal to or a dash?
It's equal.
Okay, why? I don't know. I'm seeing a dash.
It's probably a resolution thing.
Okay.
Okay, yeah, this is an equal, and I'm going to share the code with you anyway. And of course, if you have questions after the talk, feel free to contact me. You'll have the presentation, and in the presentation, there's my contact info. Okay, we're going to use Postman. So update is exactly the same thing, except that instead of insert, it uses find one and update, and it checks if it already exists or not. Yeah, same thing for delete, except that it uses remove. Okay, so now let's wrap up and test this. So this is our database. We do not have any records. We'll go to Postman. Oh yeah, just one more thing. So since I missed the validation of UUID in get, see here, ID exists, there should be another thing saying that query underscore ID dot, like I'm not sure, I need to read the documentation again, but something like is UUID in order to prevent the error that I already got. Remember when I entered one and our friend helped me find out that it's the wrong type? So this is why enforce types as well. So sometimes you need to enforce a Boolean or integer or positive integer and so on. So this is where you define these validation rules. Okay, so back to Postman. This is the collection I created. So let's get a non-existing expense. So you can see the status here, 404 not found. And this is the body that was returned. Now let's insert. So you see in new, it's a post verb. So we're posting to the same URL, which is expense. So if we get to get, it's exactly the same URL. It just has this extra because we're using the query. However, if I remove this, it's still the same, but it does not have the query ID. So it's saying the ID is missing. So this is exactly the same as this, except that this is post, this is get. So let's post a new one missing the amount. And now it says invalid value of amount in the body. So let's make it right and send. So now it says success, and this is your object. So if we go to the database, we have our object. Let's get this object. So we have the ID. We're going to get it by ID. And this is our object. Let's update the expense. So again, same thing, but patch. We're gonna provide the ID. So let's not provide an ID. It says the ID is invalid. So I want to update this object, which does not exist, with this new name. So it says the object is not found. So I'm gonna insert an existing object, and I'm going to change the name to new name, because what's the name of it? It's test. So we're gonna change test to new name. So now our object is new name. And now we have a date modified as well. So if we go to the database and refresh this, now we have new name. And finally, let's delete our expense. Let's delete a non-existing one, and it says not found. Let's delete the right one, and it will say success. If we go to the database, there's no entries. So this concludes our talk. I'm going to send you this first. So I'm gonna make a new zip since we changed some things. Oh, whoops, okay. So a mistake I made is I forgot to delete node modules. So when you upload your project to GitHub, for example, or to any Git repository, you need to exclude node modules, and you also need to exclude your configuration, because your configuration files includes your real passwords. So you need to exclude your environments, and you need to exclude the node modules. And it's really good that we noticed this, because I don't want to share with you my passwords. So all you need to do to make it work is copy the template file, rename it to dev.env, which I'm going to do it for you, dev.env. And now you just need to change the parameters. And I deleted node modules because it has a lot of space. And all you need to do to regenerate it is simply npm install. So I'll add the README file. So dependencies, npm initial run requires npm space I. This will install all the dependencies and create your node modules. And then to run it, you just say node index. Okay, so now let's zip this. And okay, I'll just wait for it to get uploaded, and I'll send it to you in the chat directly. Okay, so chat. Okay, so this is everything you need, including all the resources and okay, so keep in mind, not all NPM packages may be trustworthy. The good practice is usually to only update manually. Do not let it automatically update. However, keep an eye on updates because a lot of times there are security issues. So keep an eye on updates. This is just a demo. We did not talk about security seriously, nor did we go into the details of any component, nor did we best practices. There's going to be a talk. The next talk is going to be about graph databases and document databases specifically. I intentionally use different ECMAScript styles. Check out what ECMAScript is. While I try to use best practices environment, the purpose of this talk is just to get you started. So the code is not production ready, even though it works. We did not go into any details regarding code structure. This is what someone asked about, MV, MVC, MVVM, and so on, nor design patterns such as microservices versus monolith, and so on. There's always more to learn, but even more to innovate and excel. Avoid falling into the cargo cult trap. You are not Netflix or Google just yet. I really recommend reading this and this and this. These three are about this last point. And that should be the last one. Yeah. Any questions? If you have a question, probably someone else has it as well. They just don't want to ask it. So go ahead.
In the node, the index.js file.
Okay.
Would it be fair to say it's split up into kind of 3 different sections there, where you have a kind of setup or like a init, and then like actions, and then sending it out to the front end?
Well,
like, you know.
Yes, this is not the best practice of creating an index file. The best practice would split middleware into their own files and routers into their own files. And
Okay.
yeah, what's left is the initialization and required things and the actual running of the server. Sometimes, okay, so I'm gonna stop recording here.